Good day and welcome to Big Bad Tech. I'm your instructor Jim Pytel, and this is the Basic Electronics series. This is a brief introduction and orientation of the Basic Electronics series, as well as recommendations on how to use this content to further your educational goals. The Basic Electronics series consists of 3 separate playlists: DC circuit analysis, single-phase AC circuit analysis, and 3-phase AC circuit analysis. Each playlist is a sequentially arranged series of free online lectures designed to support a flipped classroom approach to teaching basic electronics. The flipped classroom approach to instruction uses online lectures to deliver instruction outside the class and activity-based learning and lab exercises inside the class. Students watch lectures at the time and place of their own choosing, at their own pace, and concept engagement and application takes place in the classroom with the guidance of an instructor. Advantages to this instructional approach can be numerous. The online content is flexible, accessible, and can be paused and reviewed to support the learning process. Commute time, travel expense, and textbook expense for students is dramatically reduced and allows students with family and employment obligations to remain enrolled in school. Whether you use this content in class, independently use this content to brush up on specific skills, supplement or replace a textbook, or just make up for a class you skipped, I hope you find it useful. The Basic Electronics series teaches circuit analysis from the perspective of conventional current using algebraic, i.e. non-calculus methods. For the most part, the order within the playlists represent the sequence in which the material is intended to be presented. The complete Basic Electronics series is intended to be delivered over the course of 3 10 to 12-week academic quarters, which include a weekly supporting hardware lab with the guidance of an instructor. The series starts with a DC circuit analysis playlist, which begins with a review of basic technical math, engineering prefixes, and unit conversion. Take this first section seriously because it establishes standard operating procedures that will be employed for the remainder of the lecture series. The next unit discusses basic electrical quantities like voltage, current, resistance, power, and energy on an introductory level, as well as introduces electrical schematics and important concepts like efficiency and capacity factor. Following this unit, we'll examine the property of resistance and depth, introduce fixed and variable resistors, and learn to calculate the resistance of different configurations of resistors. Additionally, this unit will cover the ohm meter function of the digital multimeter. Next, the series examines DC Ohm's law and power calculations and introduces the DC power supply, the DC voltmeter, and the DC ammeter function of the digital multimeter. Following this unit, we'll examine the fundamental properties of both series and parallel DC circuits and cover important concepts like Kirchhoff's voltage law and Kirchhoff's current law, and introduce handy shortcuts like the voltage divider rule and the current divider rule. The next unit examines more complicated series parallel circuits using a direct, understandable approach building off the previous understanding of basic series and basic parallel circuit properties. Finally, this section concludes with an examination of important circuit analysis techniques and theorems like the superposition theorem, Thevenin's theorem, and the maximum power transfer theorem. The content up to this point might typically be packaged into a traditional 10 to 12-week academic quarter. The next 10 to 12-week academic quarter still uses the DC circuit analysis playlist and covers the transient DC analysis of 2 energy storage devices, the capacitor and the inductor. Then, the series moves on to the single-phase AC circuit analysis playlist, where we introduce basic sinusoidal properties like peak and RMS value, frequency and phase shift, and learn to use the function generator, the oscilloscope, and the AC voltmeter and AC ammeter function on the digital multimeter. The series then moves on to discuss complex number math used to represent sinusoidal properties in a convenient format known as the phasor. As previously, I'm encouraging you to take this section on complex number math seriously because it establishes standard operating procedures that will be employed for the remainder of the series. These foundations having been established, the series then moves on to discuss AC Ohm's law and quickly moves into the discussion of basic series AC circuit properties, basic parallel AC circuit properties, and finishes up with an examination of more complicated series parallel AC circuit analysis. This section of material again might be typically packaged into a traditional 10 to 12-week academic quarter. The last section of the Basic Electronics series starts off with an examination of AC power, including apparent, real, and reactive components, as well as power factor correction. Next, the series examines an incredibly useful device known as the transformer. The series then moves on to discuss important AC circuit analysis techniques and theorems like the AC superposition theorem, AC Thevenin's theorem, and the AC maximum power transfer theorem. Following these topics, the series moves on to the 3-phase AC circuit analysis playlist and examines balanced and unbalanced 3-wire Y, 4-wire Y and delta configurations, and introduces 3-phase AC power measurement techniques like the single watt meter method and the 2-watt meter method. Finally, the series returns to the single-phase AC circuit analysis playlist to finish up with a quick discussion of resonant and filter circuits. This section of material again might be typically packaged into a traditional 10 to 12 week academic quarter. There you have it, the complete Basic Electronics series. This content represents, in my professional opinion, the core skill set required by individuals claiming competency in electrical circuit analysis. However, represents only words and not sentences that form ideas or applications. It is for this reason the Big Bad Tech channel also includes other lectures and playlists that are unlocked once a degree of competency is reached using this content. An example might be the hydraulics playlist that makes use of basic DC circuit analysis skills and a type of schematics known as ladder logic to enable the electrical control of hydraulic systems. Another similar example might be the motor control playlist that makes use of single-phase and 3-phase AC circuit analysis skills to enable the control of motors. The idea is to include the necessary theory in the Basic Electronics series and move into applications of this theory as soon as possible. Before we bring this orientation to a close, allow me to make a brief comment about how to most effectively and efficiently employ this content. Bottom line up front, these lectures are not passive resources, but rather necessitate the active participation of the viewer. Most lectures feature applications of theory in the form of numerous illustrated example problems. If there is a single piece of advice that I can deliver about getting the most out of these lectures, it is this. Pause the lecture when asked to do so and attempt to solve the example problems by yourself using the previously discussed theories. If you're struggling, the lecture content will guide you to the correct solution. Watch this material as many times as you want, wherever and whenever you want. If you need more time, feel free to pause the lecture to take notes or rewind to review material you may have missed. You can't do that in a traditional lecture, but here at the Big Bad Tech channel, you are the one that is in charge of your education. Historically, most students do well and enjoy the flipped classroom approach. However, it does take effort, discipline, and good study skills. Final grades for most classes I've taught using this approach can be described as bimodal, in that there is a large number of students that succeed and a small number of students that do not, with very few, if any, students in the middle. My succinct analysis of this historical trend is this: do what your instructor tells you to do. Don't do what your instructor tells you to do. Here's what I'm telling you to do. Actively participate in these online lectures and pause them when asked to do so and attempt to solve the illustrated example problems on your own. Pause, rewind, and review the material as needed. Take notes and get involved. Show up to lab prepared. Take charge of your education. Commit to the task and succeed. It will not be easy, but you can do this, and these free resources are here to assist you wherever and whenever you need them, as many times as you need them. Before we bring this brief orientation to a close, I'd like to answer some questions of interest to numerous viewers. One of the questions I'm most frequently asked is, can I use these lectures in my class and/or business? The answer is a most emphatic yes. Use this content. Use it at home, use it at work, or use it at school. Put this content in playlists, embed it in websites, share it with your coworkers, family, and friends. I made this content and I posted it on YouTube so users everywhere have free access to this information. This being said, this YouTube channel is meant to be the sole point of distribution for these lectures. Users are not authorized to download content, change content, or charge for access to this content. Do not even think of downloading this material and uploading it to your own channel, pretending it's your own work. Not cool. Use this material, and please let your friends know these free resources exist. In summary, use it, don't steal it, be cool. The second most common question I'm asked is this: can you help me with my homework, lab, or project, or fix or design something for me? That answer is a polite but firm no. I am adamantly not open to these possibilities. I simply cannot be everyone's personal tutor or personal engineer on call. Unless you are one of my students, you are on your own. Another common question is this: I noticed an inconsequential rounding error, a minor misspelling, a small mispronunciation, or you hurt my feelings. What is the accepted standard for redressing this error? Good question. My recommendation is to make a super big deal about it. Shout at your computer and throw things at it. Write an angry screed in all caps in the comments section. Cancel your subscription to the internet. call your mommy, and threaten to fight me. No, seriously, my recommendation is to just deal with it. Listen, the Big Bad Tech Channel has the production quality of a 1980s Bananarama music video, and there is bound to be minor mistakes that reasonable humans can overlook and overcome. If, however, you really do notice a major error, politely notify me as soon as possible and I'll make a correction. Oftentimes the corrections take the form of a floating card or annotation or an explanation in the information or comment section. Most of the time, someone has already noticed the error and a correction has already been issued. If, however, you really are the first person to notice the error, please let me know and I'll make the change. Last but not least, a lot of folks ask me why I'm doing this. Well, it's certainly not for the money. By the way, this reminds me, if you want me to keep doing this, throw me a bone and click on an ad every once in a while. Honestly, I started doing this on a lark because I thought the electromechanical engineering education world was in desperate need of my own special brand of sarcasm. However, the more I started doing this, the more I became convinced this method works. When you get right down to it, the Big Bad Tech Channel is all about power. When I use the term power, realize I'm only tangentially speaking about the time rate expenditure or production of energy measured in watts. What I'm more directly speaking of is your ability to control and influence your own path. This channel is all about enabling you to gain the confidence and skills necessary to contribute to a more powerful community, a more powerful country, and a more powerful you. In closing, the material at the Big Bad Tech Channel cannot, will not, never makes the claim to replace time in a safe and supportive lab environment. The content at the Big Bad Tech Channel, at best, represents the minimum understanding necessary to even enter a lab. This being said, imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest. Remember to tell your Lazy Lab partner about this resource and be sure to subscribe to the Big Bad Tech Channel. You'll be the first to know when new content is made available.